Hello my dear students. Today we will be learning about sound and standing waves. Now for our review, this is what a sound waves would look like. This is only a string, but if you pluck them, it forms waves and cause the sounds by vibration. But the sound waves cannot travel through space. It needs medium to travel. At the room temperature, sound waves travel about 340 meters per second. And the standing waves in physics are waves that oscillate. That means it is a kind of waves that moves back and forth in a pendulum, just like this. Okay, for a better understanding, let's say this is the part of sound waves. This is the node. The node is the part which air cannot freely in or out. The antinode is the location in which the air moves freely in or out. And in our diagram, this part here is the node in which the strings cannot be plucked, just like this. The strings move here, but it doesn't move there. This will be our antinode because the strings is moving up and down, and there is no movement at all. So that it is here. In our waves, the middle part of the wave, this is our node, and the upper part of our wave, this is our antinode. This is where the waves are freely moves, and this where the area that our waves cannot move. Okay? And if you understand what is standing waves and sound waves, let us make a little experiment. Today's experiment, I will be using 3 different types of glass bottles, 3 different sizes and shapes. Number 1 bottles we'll use is the Red Horse bottle because this is the available in my house. And we will be also using the 1 liter Coca-Cola. And the last one, the smallest, is we will be using a Cobra. Let us make sound out of this from the mouth of the Coca-Cola. Now, in our discussion a while ago about the standing waves, in this particular object, air moves freely in this section, which is the mouth, the opening area of the Coca-Cola, and the air cannot move freely here at the bottom part when there is no vents. Now let's try making a sound from it by blowing air into the bottle. As you blow air at a moderate speed, the turbulence of the air makes the Coca-Cola bottle to vibrate, causes a sound wave. What you are hearing now is a lower frequency wave. Now let's try with the other bottles. Sabra bottle. Now let's try the bigger one, the Red Horse glass. That is the first harmonic. Now let's do the third harmonic part of the much higher frequency with this. As you can see, we can hear a much higher pitched voice. Now let's test the other bottles. Now, the height of the bottle is 1/4 of the total wavelength. The height of the Cobra, this must be around 12 inches. Times 4, our sound waves will be 48. Let's try the Coca-Cola. Now let us try the 5th harmonic, or the higher pitched voice. You see, it is much higher pitch. Let's try with the other bottle. Now let's try with the Red Horse bottle. Now let us ask some of our audience here in my studio on how does waves form in the glass of bottle. Yes, you! Hello! I am the audience. I am going to explain to you how the waves form in the glass bottle. For the explanation for that, this is the bottom part of the glass bottles where air cannot move freely. And this is the antinode in which the part that air can move freely because this is the vent. the air can move back and forth in this. But this is a closed area, the bottom part of the bottle, in which air cannot flow. Here, let me show you. In this Cobra bottle, the bottom part has no vents, has no airway. This is closed, so this is our node. And this area here is open when we can blow some air like this. The node here, when we blow air from the antinode here, the wave here is only 1/4 of the height of the actual wave. Okay, so 4 times the height of the glass bottle is equivalent to the height of the wave. Okay, but the height of the bottle is equivalent to the 1/4 of the wave. Now here for the third harmonic, this will be our node, and as the air goes here in the antinode, it goes right here. As we can see, we have a one antinode and the other antinode here, and so we have 2 antinodes, and there we have 2 nodes. This produces a slightly higher pitch sound or higher frequency sound. Now here for the 5th harmonic, this is a higher pitch sound that we can produce. Let's have 1, 2, 3 antinodes and 3 nodes, which produces a higher frequency sound. Now let's test it out. For our first example, the first harmonic, like that. The third harmonic will be like this. And the 5th harmonic will become like this. I really hope guys you understand our lessons for today about sound waves and standing waves. Bye! That's all for today's video. This is Neil Yano, your teacher for today.